Okay. So once you do the transformations of data and convert dummy variables, you may end up with a really, really large number of columns in your data set. Okay. The larger the number of columns, you will need more rows of data to do a reasonable analysis. So you have to be mindful of how many columns you end up with in your data set. So the more variables we have, the more complex the model will become. So we need to make sure that we keep only the variables that are important for prediction. You don't just keep variables just for the sake of it, right? So the more variables you have, more rows of data we need. Okay? And if you have many variables in the model will become less robust. So that means it will not give you consistent results, consistently accurate predictions. The more complex the model, the less robust it will be. Okay. So smaller the model, like other things being equal, a smaller model is better than a bigger model. Okay, you don't need to add more complexity, and that's not a good idea without any gain in predictive ability. Okay, so other things being equal, parsimony or compactness is desirable. Okay, smaller model is desirable. So just a rule of thumb: how many variables and how much data. So you have approximately 10 records per variable, which is really not a very high number, so you can always get that unless you're designing an experiment. If you're collecting data that's coming from the internet, this is not a major bottleneck. And so here is a sort of thumb rule: 6 times m times p, where you have m is number of outcome classes in your target. So if your target has only 2 classes, then you put 2 there. If you have 3 classes, you'll put 3, and so on. And one other important criterion is redundancy must be avoided. Okay? Because if you have 2 variables that are about the same, you get what is called collinearity. The collinearity means that they both have the same type of relation to the target, so they each are competing for the same predictive power with the target. So these two competing with each other will pull each other down, and you don't get good results. Okay, like for example, if you have employee database, you have age and experience. Okay. And age and experience are likely to be very highly correlated. Okay. Older people have more experience, right? So only one of them is sufficient. Okay. There is redundancy there. So you can get rid of one of the 2 variables. So that's what this means. And oftentimes it may not be as clear as age and experience. Okay. There may be variables that an analyst may not know that they are redundant. Okay. So you have to consult the domain area expert and discuss with them to figure out what variables are important and what variables are redundant. Okay. All right. So the next concept, well, let me